Hi guys, Mr. Math is back. Going over AMC 10A 2021 fall. In this video, I'll be looking at numbers 11 through 15. Right, this is where the test starts to get a little bit harder. Right, always after number 10 is when you start to see pretty significant difficulty spike. And I will say that some of my solutions are not what I would consider the most efficient way to do the problems. Mostly this was just sort of my first attempt to do these problems. So please, I encourage you to tell me if you find a more efficient way to solve the problem. I'm very interested to hear about that. Okay, so please let me know. All right, so let's get started. All right, I'm gonna start number 11. Emily sees a ship traveling at a constant speed along a straight section of a river. She walks parallel to the riverbank at a uniform rate faster than the ship. She counts 210 equal steps, walking from the back of the ship to the front. Walking in the opposite direction, she counts 42 steps of the same size from the front of the ship to the back. Okay, so to start this problem, I set up a couple of different variables. One I called VE to represent, this would be Emily's velocity, Emily's speed, right? And the unit of the unit of this would be steps per minute. And honestly, the unit of time really doesn't matter. You can make it steps per second, steps per hour. It doesn't make a difference. So VE would be Emily's speed, and then VS would be the ship speed in the same unit of Emily's steps per minute. Okay, so that just allows me to, deal with just the same units, right? Which is obviously going to make the math much, much easier. Just going to kind of move this out of the way. So that's just sort of establishing my variables, VE and VS, right? And then what I did was I assumed that the length of the ship, so if I sort of draw the ship and say, how long is it? It's K steps total in length, right? So K represents sort of the length of the ship in the unit being Emily's steps, right? So how many of Emily's steps it takes to get from the back of the ship to the front of the ship, right? So now if we think about this, so now if the ship is moving in the same direction that Emily's moving in, right? Then if you think about it, every minute, Emily will cover VE minus VS, right? And the reason for that is because if she's moving at the same time that the ship is moving, then so let's say like in 1 minute, so if we kind of think about like the ship and then Emily, right? Oh, that's not a great stick figure. If we think about the ship moving at the same time as Emily, right? Then every minute the ship will move VS steps and Emily will move VE steps. So therefore, if they're both moving at the same time, then Emily's only sort of advantage over the ship is the difference in their speeds, right? Because she's moved VE, the ship has moved VS. So therefore, her distance relative to the back of the ship is VE minus VS, right? So that's how we can think about it in terms of how much sort of distance across the ship she's making every minute, right? So now what we can do is we can say, okay, so remember, if we decided that the length of the ship is K steps long, right? Then we can say for Emily's time to cross, right? Time to cross is going to be K divided by VE minus VS, right? Now this represents the length of the ship divided by the distance she moves every minute, right? So what that's going to do is that's going to give us that would give us the amount of time that it would take her to get across, right? Because it's sort of like this would be like, K is in steps, and then VE minus VS is steps per minute. So that would give us a unit of minutes, right? So if we multiply that by VE, which is Emily's speed, right, that should tell us how many steps it would take her to get to the end of the ship while the ship is also moving in her same direction. So K divided by VE minus VS times VE is 210, right? Now, if the ship moves in the opposite direction to her, then if anything, she's gaining more distance per minute, right? She's actually getting her distance plus the ship's distance, because the ship is going this way, she's going that way, then her distance is VE plus VS, right? So every minute she's getting a distance VE plus VS relative to the front of the ship, right? Or back of the ship, depending on which part of the ship she starts at. So in that situation, we would say K divided by VE plus VS times VE equals 42, because she counts 42 steps when she goes opposite of the ship, right? So again, I'm just going to try to make this a little bit smaller so I can kind of get it out of the way here. Not too small, just enough to, whoa, not what I wanted to do. Just to kind of get it out of the way there. Now, if I want to solve, so what do we want? We want the length of the ship. So we want to solve for K, right? Now, if we, how can we do this? 42 VE. So let's say we solve both of these equations for K, right? So this equation here, we solve for K, and this equation here, we also solve for K. Well, if we solve both of those equations for K and set them equal to each other, actually, we can solve both equations for KVE, right? K times VE, K times VE. So, and then setting those equal to each other, we would get 210 times VE minus VS is equal to 42 VE plus VS, right? And then if we sort of, distribute that out and solve for VE in terms of VS, we get the following. We get VE is equal to 252 over 168 VS, right? And that's just from solving this, right? It's just sort of, I'm just sort of, skipping some steps to save time. Because remember, you're not allowed a calculator, so you have to do this all by hand. Right? Now, what I then did was I substituted this quantity, 252 over 168 V, oh, sorry, that should be an S, not a 2. Right, by substituting that into the top equation, this one, right? So essentially taking like this, right, and plugging it into VE and VE, right? So here and here, you end up getting an equation. I'm going to make everything a little bit smaller again, just because there's really not a ton of room here. So if we do that, then we get the following equation. We get K times 252 over 168 VS over 252 over 168 VS minus VS equals 210. And now notice how the VS's can cancel out, right? This cancel, cancel, cancel. So we're basically left with K, whoops. We're left with K equals 210 over 252 over 168 over 252 over 168 minus 1, right? And then if you multiply everything by 160, if you take this bottom fraction down here, like down here, and multiply everything by 168, you get 252 over 252 minus 168, which is 252 over 84. So basically we're doing 210 divided by 252 divided by 84, which becomes 210 times 84 over 252. And then what I did was I sort of factorized these numbers so I can cancel out common factors. 84 is 21 times 4. 252 is 63 times 4. So this is 21 times 4, and this is 63 times 4, which basically leaves you with a 3 on the bottom. So you essentially just end up with 210 over 3, which is 70. So 210 divided by 3 is 70, right? Which is answer choice A, right? So the answer is A. And again, like I know that this was not the most efficient way to solve the problem. Again, this is just purely, this was like my first, a lot of times when I'm first working through an AMC 10, I sort of I call it like the brute force method. I just sort of do whatever I can do to get the answer. And then later on, I think about the problems and find better ways, but I didn't really have time to do that. So if any of you can tell me a more efficient way to solve the problem, please, I'm very interested to hear that. Number 12. Oh, gotta move this out of the way. Okay, so number 12 says the base 9 representation of the number n is 27006000252 base 9. What is the remainder when n is divided by 5? So hopefully you guys have a pretty good understanding of what what a base 9 number is. Right, it essentially means like the number with the where instead of it being 10 powers of 10, it's powers of 9. So if you were to write out the number, essentially what you're looking at is 2 times 9 to the 0 plus 5 times 9 to the 1 plus 0 times 9 to the 2 plus 0 times 9 to the 3 plus 0 times 9 to the 4 plus 0 times 9 to the 5 plus 6 times 9 to the 7 plus 0 times 9 to the 8 plus 0 times 9 to the 9 plus 7 times 9 to the 10 plus 2 times 9 to the 11, right? So that would be the number in base 10, right? I should make sure I did that. Yeah, 9 and 2 is 11, right? Yeah, because we have 0, 0. Oh, wait, sorry, I think I made a mistake because I forgot that it's 0. So it goes 0, 1, 2, 3, 4, 5, 6. Okay, yeah, I made a mistake. I did this before too. This should be 6, and then this should be 9, and then this should be 10. Now, I will say that for this problem, let me draw that better. I will say that for this problem, I used modular arithmetic. So I'm hoping that some of you have knowledge of modular arithmetic. I taught a course called Discrete Mathematics, in which we did things like non-decimal bases and modular arithmetic and number theory. So hopefully you guys have some understanding of, modular arithmetic. If you don't, I would suggest, maybe looking up, and it's not like, it's just sort of the basics of modular arithmetic. So maybe you might just want to find a video, or if not, write a comment and I can make a separate video talking a little bit about, what type of math I'm doing here. Essentially, modular arithmetic is like dealing with the remainder when you divide by a number. So, and remember, because we want to find the remainder when n is divided by 5. So essentially what we're looking for is, if this is n, right, we're looking for n mod 5, right? So I'm looking for 2 plus 5 times 9 to the 1 plus 6 times 9 to the 6 plus 7 times 9 to the 9 plus 2 times 9 to the 10 mod 5, right? Now, the nice thing about this is that there are many different rules that we can use that can make a lot of this math easier And again, I'm not going to be proving everything that I say. So if you need sort of a proof or anything, just kind of let me know. But let's say, for example, we can say that A is congruent to B mod C, right? If this is known to be true, then we're also able to say that, so I can say this implies A to the N is congruent to B to the N mod C. And it's actually not too hard to show why that's the case. It generally uses binomial expansion to prove that this is true. But yeah, it's pretty fairly easy to see why that's the case. And what's really nice about that is that this is going to make this whole thing really, really, really easy. Not really, I mean, much easier, right, than normal. The reason why this is really easy is because we know that 9 is congruent to 4 mod 5, right? Another way that we can say this is we can say that 9 is congruent to -1 mod 5. And that's really the key here, right? That's what's going to make things really easy for us, knowing that 9 is congruent to -1 mod 5. Because what that's going to do is that's going to allow us to say that 9 to the n is congruent to -1 to the n mod 5. And this is pretty easy to work with. So we're going to use that to our advantage. But before we even do that, I'm going to get rid of a couple. I'm going to simplify things even more. Now, one thing we know that this is divisible by 5 because it's 5 times 9, right? And because it's divisible by 5, that means it's 0 mod 5. So we can just turn that into a 0. Now, this 6 times 9 to the 6, right? Well, let's think about it. Is there another way we can write that? Can we think of 6 times 9 to the 6 as being 5 times 9 to the 6 plus 1 times 9 to the 6, right? And again, we know this is divisible by 5, which means it's 0, right? So we can just write 0 plus 1 times 9 to the 6, right? And then if we look at here, 7 times 9 to the 9, again, that would be 5 times 9 to the 9 plus 2 times 5 to the 9. And 5 times 9 to the 9 is divisible by 5, so we're going to write that as 0 plus 2 times 9 to the 9. And then we're going to write, and this we can't exactly simplify because it's only 2 of them. So we're going to leave that how that is for now. Right, and again, this is mod 5, right? Now, let's simplify this by, getting rid of these zeros. Let me make this smaller so I can kind of move it out of the way. Okay, so we'll leave that over here. So essentially, what do we have? We have 2 plus 9 to the 6 plus 2 times 9 to the 9 plus 2 times 9 to the 10 mod 5. So already we've made tremendous, headway in this. Now, remember how I said earlier that 9 is congruent to -1 mod 5, right? It's 1 less than a multiple of 5. So that means we can rewrite this as 2 plus -1 to the 6 plus 2 times -1 to the 9 plus 2 times -1 to the 10 mod 5, right? And again, I'm not going to prove that now, but if you're interested to see a proof, I'm sure you could find one pretty easily online, or again, just send me let me know that you would like me to explain where that comes from. But this is going to make our job so much easier because this is going to be 2 plus 1 minus 2 plus 2 mod 5, right? Because -1 raised to an even power is 1, and -1 raised to an odd power is -1. So how does this simplify? Well, these cancel out, so we're just left with 3 mod 5. So what does that mean about our number? It means that our number n, right, is congruent to 3 mod 5. Or in other words, the remainder when n is divided by 5 is 3d. Okay, so again, I used modular arithmetic. I'm sure many of you could have found a different way to do it. I'd be very interested to see any other solutions. So please let me know if you have another way to do it. Okay. All right, let's look at number 13. Let's see. Oh yeah, I remember this one is not too hard. Each of 6 balls is randomly and independently painted either black or white with equal probability. What is the probability that every ball is different in color from more than half of the other 5 balls? So the way that I really thought about this was to say, okay, if every ball, so there's 6 balls, right? Either black or white. What is the probability that every ball is different in color from more than half of the other 3 balls? More than half of the other 5 balls. I mean, well, to be more than, what's more than half of 5? More than half of 5 is 3 or bigger. So we need every ball to be different in color from at least 3 other balls. Well, can every ball be different in color from exactly 3 other balls? Well, yeah. If you have black, 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 white, 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 then every ball is different in color from 3 other balls because there's 3 of each color, right? Can every ball be different in color from 4 other balls? That's not possible because let's say you have blue, blue, white, 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 white. Well, the blues are different in color from 4 of the others, but the whites are not because they're only different in color from 2, which is less than half. So the only way that this is going to be possible is the situation where 3 of them are blue and 3 of them are white. So we just need the probability that 3 of them are blue and 3 of them are white. Well, how many ways can we paint them in such a way that 3 of them will be blue, right? Well, out of the 6 balls, we would just need to choose 3 of them that we would paint blue, right? And then once those 3 balls are chosen, then the remaining 3 would be white. So there's 6 choose 3 ways to paint exactly 3 of the balls blue, black, I mean, I'm sorry. Now, what are the total number of ways to paint the balls? Well, each ball can either be black or white, 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 black or white. So there's, right, 6 different balls, 2 choices per ball. So 2 times, so that's going to be what? 2 to the power 6, right? 6 choose 3 is 6 times 5 times 4 over 3 times 2 times 1 over 2 times 2 times 2 times 2 times 2 times 2, which would be, these cancel with the 6. So we get 2 times 2 times 5 over 2 times 2 times 2 times 2 times 2 times 2. Cancel, cancel. 5 over 2 to the 4 is 5 over 16. So we have a 5 out of 16 chance that the balls would be that we would have this situation that we're looking for, right? That each ball is different in color from more than half of the remaining 5 balls. So I thought this one really wasn't that hard. You know, for a probability question, it wasn't. I've definitely seen worse, so I didn't think it was really that bad. Okay, let's look at number 14. 14, how many ordered pairs x, y of real numbers satisfy the following system of equations? Okay, so we have this system of equations. We're looking for ordered pairs of real numbers that are on both of these equations. So first thing I did was I wanted to be able to like these types of problems, I always want to be able to visualize. It helps me a lot if I can draw the situation. So looking at this first equation, I kind of thought, well, what does that look like? Well, if you simplify it, you get y equals -1/3 x squared plus 3, right? That's how we can sort of rewrite that equation, right? Which, if we think about it, that's actually pretty simple to draw. That's just a parabola that's like very wide and it faces down and goes through 3, 0, right? So this would be the 0, 3, I mean. right? 0, 3. In terms of x coordinates, it would go through 3 and -3, right? So this would be 0, no, 3, 0, and -3, 0. Right? Okay, so we got that. Now let's look at the second equation. So let's look at this equation, right? So we'll call it number 2. So for that one, we could start by square rooting both sides, right? So we could say absolute value of x plus absolute value of y minus 4 is either going to be equal to 1, or absolute value of x plus absolute value of y minus 4 equals -1, right? Because both of those values would square to equal 1. Okay. So in other words, we have either absolute value of x plus absolute value of y is equal to 5, or absolute value of x plus absolute value of y is equal to 3, right? Now, if you try to, this isn't as bad as it seems. I generally don't like problems involving absolute value because they kind of mess with my head. But it's actually not as bad as you might think. Essentially, the easiest way to deal with problems like this is to think about different cases, right? So look at, this first one, right? This one. And now think about what happens when x and y are both positive, right? So x and y are both positive, right? So in that case, so that would mean that you're in the first quadrant, right? Well, that just means x plus y is 5, which means y is equal to -x plus 5. So -x plus 5, right, is going to look, whoops, not what I wanted to do, is going to look like this, right? Because it's going to have a y-intercept of 5 and a slope of -1, right? So that's going to go through 0, 5, right? 0, 5, right? But then it's also going to go through 5, 0. Now, what happens when x is negative but y is positive, right? Well, when x is negative and y is positive, you have -x plus y is 5, or y equals x plus 5. So y equals x plus 5 in the second quadrant is going to look like this, because again, it's going to go through 0, 5, and it's going to have a slope of 1. What about when x and y are both negative? Well, then you have -x minus y equals 5, which means y equals -x minus 5. -x minus 5 looks like this, right? And what about when x is positive but y is negative? You have x minus y is 5, or y equals x minus 5, which is going to look like this, right? And now, if we think about it, that's already given us 2 possible solutions, right? That's already going to give us 2 possible solutions because it's going to have to intersect with those 2 bottom lines down there. Right? Yeah, because if you think about it, when x is -3, y is 0. So that means that as you go below that point, it's going to have to intersect I mean, you can just kind of tell by looking, like it's going to have to intersect this line because it's continuous, and we know it cuts through at -3, 0, so it's going to have to cut through that line in order to continue down to minus infinity, right? Or otherwise it wouldn't make sense. It would be stuck in that triangle, which it's obviously not. And then same situation over here. So we already have 2 possible solutions. Now, if we look at the second equation, this one, it's really the exact same situation that I just did, just with being 3 instead of 5. which means in the first quadrant, it's going to look like this. Second quadrant will look like this. Third quadrant will look like this. Fourth quadrant will look like this, right? Where everything's just 3s instead of 5s, right? So this is 0, -3. This was 0, -5, right? Sorry, that's supposed to be a negative. Just fix that. That's supposed to be negative. Right? And now if you think about that, obviously that has to connect here, here, and here. So that adds 3 more solutions to it. So if you add that up, we have 5 solutions total. So I think in my opinion, that has to be the easiest way to do it. I mean, maybe some of you can think of it more algebraically, but I'm a very visual person, so I like to draw the situation. So again, I'd be very interested to see if anyone had a different approach to this problem. Okay, all right, and then last but not least, I'll go over 15. Now, I will say that for this problem gave me a lot of trouble, gave me a very hard time. I remember working on, this was one of the first problems that I worked on. And I definitely think that my solution is not the most efficient way to do this problem. I essentially used coordinate geometry, and it was not pretty. I'll tell you that. So this is definitely a problem where I would really like to see if someone can give me a better way to do it. And again, like I really haven't, I sort of did it the one time and then haven't really gone back to look at it again. So, all right, we have triangle isosceles triangle ABC has AB equal AC equals 3√6, and a circle with radius 5√2 is tangent to line AB at B and line AC at C. What is the area of the circle that passes through the vertices? Okay, so if we draw a triangle, right, and we say A, so this would be like BAC, and then we have a circle that kind of cuts through like this in a way that it would be tangent. Oops, let me do that better. In such a way that it would be like tangent to these lines, right? And then our question, and what do we know? We know this is 3√6, and we know this is 3√6. And then we know that if we were to draw the radius of the circle like this, that this is 5√2 and this is 5√2. We also know that these would make 90-degree angles, right? Because a radius is always perpendicular to a tangent line at the point of tangency, right? So let's see, this is, 5√2, right? Okay. So what did I do? Now essentially what do we want to find? We want to find the area of this circle, the circle that passes through A, B, and C, right? So, all right, let's think about this. So first thing that I did was I found the diameter of the circle. No, not the diameter of the circle. The height of this. Let's say we call the center of the blue circle. Let's say we call that center. I guess we'll just call it O. Actually, you know what? I'm going to call it D, because I'm going to call the center of the circle we're trying to find O. Right? So I'll call this point here O, right? And essentially the first thing I did was I found the distance from A to O. I'm trying to draw that better. From A to O, right? Which I did by using the Pythagorean theorem. So because again, we know that this is a right triangle, so I can use Pythagorean theorem. So 3√6 squared plus 5√2 squared equals, let's call it C squared, right? So that's going to give me 9 times 6, which is 54, plus 25 times 2 is 50, equals c squared. So that means c squared is 104. C is a square root of 104, which is what, 4 times 26. So that would be 2 root 26. Right? So that tells me the distance from A to O is 2 root 26, right? Now, I can also find the area of triangle ABO, right? I can find the area of this triangle. So essentially like this area, right? And I can find that by using 1/2 3 root 6 times 5 root 2, which would be what? 15 root 12 over 2, which is 15 times 2 root 3 over 2, or 15 root 3. Right, so I know that the area of the triangle AOB, right, again, this triangle, right, is 15 root 3. But if I draw, I also know that if I, use this length here, so if I go from here to here, right, and I draw this as being sort of being an altitude, I can also find the area of that triangle by doing 1/2 AO times B, we can call this point D, I guess, to give it a name, right? So BD, right? So 1/2 AO times BD. So, right, which we know AO is 2 root 6. So we can say equals 1/2 times 2 root 26 times BD, right? So is equal to 15 root 3. So by solving that, I can then say that BD is equal to 15 root 3 over root 26. Right? So BD is equal to 15 root 3 over root 26. I'm going to erase some of this to give myself more room. I'm going to need a lot of room here. Okay, so that tells me that, okay, so BD is 15 root 3 over root 26. Now, what I did was I used coordinate geometry. Now, the reason why I did that is because I know that if I want to, so if I have a triangle, oops, so the thing is, like, what I need is I need to know where the center of this circle is, right? So if I draw a triangle and I want to find the center of what's called the circumcircle, the circumcircle is the circle that goes through all of the vertices, right? The way that you find the center of that circle is by finding the intersection of the perpendicular bisectors. Whoops, which I did not do very well right now. Just say it goes through that, right? Which I know this, probably not correct, but so we would say, like, so that would be sort of the center of the circle, right? Is the point where the 3 perpendicular bisectors meet, right? So if I can just find those perpendicular bisectors, I can find sort of where the center of the circle is, and then I could just use the distance formula to find the radius of the circle, and then obviously that'll get me the area of the circle. So what I did was I called point B 0, 0, right? So starting at point B down here, I called that point 0, 0, right? And then now point D, right? Point D would be 15 root 3 over root 26, 0. Right, so I'm going to just erase this for a second, just so I can kind of write that. So 15 root 3 over root 26, comma 0, right? And that's going to be point D, right? Now, point A, I needed to, again, use Pythagorean theorem to find the distance AD. Right, because I know that this distance here is 3 root 6, and I know that this distance, this distance here is 15 root 3 over root 26. So by using Pythagorean theorem, let's say I call this, it's AD, right? So I can say 3 root 6 squared is equal to AD squared plus 15 root 3 over root 26 squared. So that gives me AD is equal to the square root of 9 times 6 is 45 minus 225 times 3 over 26, right? Which I actually just left like that for now. Yeah, so I just kind of left it as that. Like I'm sure this can be simplified, but 225. Well, they both divide by 9, so I could factor a 3 out. But for the time being, I just sort of left it like that. So what that tells me is that this point up here, point A, is 15 root 3 over root 26, comma, square root 45 minus 225 times 3 over 26. Right, so that would be the coordinates of point A. So then what I did was, remember, I need to find the midpoint here, right? I need to find the midpoint and the slope. And then what I can do is I can find the perpendicular bisector and find where that intersects with this line here. And then that'll give me the center of the circle. And then I can find the radius of the circle and then do the area of the circle. So the slope of the line would be, so the slope of line AB, right, would be root 45 minus 225 times 3 over 26 over 15 root 3 over root 26, right? So that would be the slope of the line, right? Now the midpoint is going to be so the midpoint would be 15 root 3 over 2 times root 26. Because remember, it's like if I'm finding the midpoint from 0, 0, it's just going to be 0 plus 15 root 3 over root 26 divided by 2. So it's just dividing by 2, right? And then the same thing with the other one. Right, it would be root 9 times 6, 54. Sorry, that's supposed to be 54, not 45. Yeah. Yeah, these should all be 54s, not 45s. So that's 54, 54, 54, right? So, okay, so I get, so that's square root 54 minus 225 times 3 over 26 divided by 2, or times a half, right? So now if I want to find the line which passes through this midpoint, right? So essentially that's this point here, the midpoint, right? Call it E or whatever you want. But is perpendicular to line AB, then it needs to have the opposite reciprocal slope. So here, I'm going to shrink this stuff a little bit. So, oops. No, I want the whole, I want to move this back. Get that out of the way. So now what I want to do, so I use what's called the point slope formula. Point slope formula is y minus y1 equals mx minus x1, right? Where x1 and y1 are coordinates of a known point on the line, right? So in this case, I would have y minus square root 54 minus 225 times 3 is 675, right? 675 over 26, right? Over 2 is equal to that up a little bit more. Now, opposite reciprocal slope means it's going to be flipped and negated. So it's going to be negative 15 root 3 over root 26 over root 54 minus 675 over 26, right? Whoops. Times x minus, and then the x value is going to be 15 root 26 over, 15 root 3 over 2 root 26. Right? Now, I want to know where this intersects with the line x equals 15 root 3 over 26. So I essentially want to plug in that for x. Right? So what that's going to give me is that's going to give me y minus root 54 minus 675 over 26 over 2 is equal to negative 15 root 3 over root 26 over square root 54 minus 675 over 26 times, and since I'm subtracting half of it, I'm just going to be left with the other half of it. So 15 root 3 over 2 root 26, right? And by solving this, which is obviously not a pretty thing to solve, right? So what I end up getting is, sorry. So, because I want to see where these intersect, right? So by solving this, so y equals, hold on, sorry. I need to make a little bit more room here. So I'm actually going to erase some stuff really quick. Need to just make a little bit more room. So sorry, I have my notes, but I'm a little confused of what exactly I wrote here. So I'm just trying to figure out exactly what I did from this point. So what I did, okay, so let's see. All right, so it's going to be 15.3. So if I sort of simplify this, right, I'm going to get, so 15 times 15, so I get negative, okay, so I get negative 15 times 15 is 225 times 3 over 2 times 26 over so now if I simplify this thing, the square root 54 minus 675 over 26, that actually ends up giving me square root 729 over 26, which is actually nice because square root of 729 is 27, right? And this is going to be plus square root 729, 729. Over root 26. Well, half of it, right? Half of that. So now what's good about this is, so 225 times 3, 225. So that's going to be, so essentially what I'm left with, and again, I'm going to erase here so I have a little bit more room. So that's going to give me 225. So that's going to be negative 675 over 2 times 26 over 27 over root 26, right? Plus 1/2 27 over root 26. So we can write that as what? Negative 675 root 26 over 2 times 26 times 27 plus 27 over 2 root 26, right? 675. So 6. Now it turns out that 675 divided by 27 is 25. So I can rewrite that as negative 25 over 2 root 26 plus 27 over 2 root 26, right? Which would give me 2 over 2 root 26. Right, so if I come up here, that gives me 2 over 2 root 26. Which is 1 over root 26, which is root 26 over 26. Actually, or yeah, I'll just leave it as 1 over root 26. So what does that tell me? Well, that tells me that that the y value where it crosses that line, the y value of the center point is 1 over root 26. Right? So that means that the y value of the center point. So what is the center point? The center point is 15 root 3 over root 26, comma 1 over root 26, right? Now we want to find that distance from 0, which is essentially going to be like using Pythagorean theorem, right? So it's going to be 225 times 3 over 26 plus 1 over 26 equals r squared, right? So that's going to be what? 225 times 3 is 675. So that's going to be 676 over 26 equals r squared. So that means r squared equals 26. So that means the area equals pi r squared equals 26 pi. which is choice C. So again, I am well aware that this solution was not ideal. I just know that I looked at this problem for a very long time and had a lot of trouble with it. So I definitely want to give this problem more time and think about it, because I don't, obviously how I did it is not, wouldn't be effective for an exam. Probably, definitely not reasonable. A lot of very complicated math. I'm sure there's like a much simpler way to do it. And 15 really shouldn't be this bad. So I'm definitely gonna like look at this problem more and see if I can find a better way to do it. And I'm very, very interested to see what, if any of you can give me how you did it. But anyway, all right, so that's 11 through 15. My next video is going to be 16 through 20. I don't think I'm going to do the last 5 because, to be honest with you, I kind of got a lot of help on the last 5, and I wouldn't want to just sort of show, I wouldn't want to steal someone else's solutions and call it my own. So anyway, I hope this was in any way helpful. If anything, it could be a chance to kind of have a dialogue and show me your methods, and discuss the problem. So anyway, I'll see you in the next video. Thank you. Bye-bye.